Section 1.6, number 64. We're given two functions. F of x is equal to x cubed minus 4. G of x is the cubed root of x plus 10. And we're asked in part A to find f composed with g of x, or as I like to write it, f of g of x. Okay, and as well as g composed with f of x, or as I like to write it, g of f of x. Okay. All right, so let's do that. Now, for f composed with g of x, we take our f, and everywhere where there's an x, we put a g of x. Okay, so this is g of x cubed minus 4. Okay. Now, g of x is the cubed root of x plus 10. Right, so this is f of the cubed root of x plus 10. That's a 3 there. Okay. So, cubed root of x plus 10 cubed minus 4. Now, a cube of a cubed root is the original function, and since this is an odd root, we don't have anything weird happening. We just get the entire x plus 10. We don't have to worry about negatives. We don't have to worry about any of that strange stuff. Odd roots are nice like that. So f composed with g of x. The cubed root cubed just gives us an x plus 10 minus a 4. And now we combine our 10 and our 4. This is going to be x plus 6. Right. Now, g composed with f of x. Now, what we do is we take our g function, our cubed root of x plus 10, and everywhere where there is a x, we stick an f of x. So it's going to be the cubed root of f of x plus 10. Okay, but f of x was x cubed minus 4. So we're going to get g of x cubed minus 4, which is the cubed root of x cubed minus 4 plus 10. Okay, and we see that our g of f of x, the 4 and the 10 we can combine, but we're going to get a cubed root of x cubed plus 6. Okay. Now, in part B, it says is g composed with f equal to f composed with g. Okay. Now, with this one, it certainly isn't. If we let, say, x be equal to 0, right? Try x equals 0. We're going to get 0 plus 6 is equal to 0. And the other one is the cubed root of 0 plus 6, which is the cubed root of 6. Well, shit, no, that's a 6. Okay. Is 6 equal to the cubed root of 6? Well, since the cubed root of 8 is 2, and, well, so the cubed root of 6 is going to be something less than 2, so the cubed root of 6 is certainly not going to be equal to 6 since 6 is greater than 2, right? So these things are not equal. Therefore, these things are not equal. Okay? All right, so in part C, it says use a graphing utility to compute a table of values for the two compositions to confirm your answer. I'm going to forego the table. I'm just going to graph our two composition functions and see whether or not they're the same. I mean, a visual representation should do the trick as well. All right, so let's look at that on the next page. All right, so here we have our graphs of our composition functions. F of g of x is in red. That's the linear x plus 6 because the cube canceled out the cubed root and then we added the 10. Okay. And in the blue, we have g of f of x. And here, we can't cancel out the cube and the cubed root because there's this addition here. Remember, roots and powers, they play very nice with multiplications, but they do not play well with addition and subtraction. So as soon as we have addition and subtraction underneath, we're just kind of stuck with it. And we get this really interesting looking graph. The slope of it is going to be roughly 1, right, way at the ends, but it has this kind of weird hump that occurs, well, kind of between x is equal to the square root of 6, cubed root of 6, y is equal to the cubed root of 6, and we get this nice, interesting little nonlinearity happening here. All right, so these things are not equal. Their graphs are not equal, and if we constructed a table, well, the table of values, these values of x and y are certainly not equal to these values of x and y. All right, ding, ding, yeah, ding, ding there, ding there, ding there. Okay, they're not equal. Therefore, the functions